All right, so today we're going to talk about horizontal compressions and stretches of tangent functions. Let me start by saying that when we graph sine, cosine, or tangent functions, it works exactly the same way as if we had just like an x squared or an x cubed or any other just regular function. So if we have something added or subtracted on the inside of parentheses, it's going to move left and right in the opposite direction from what you would think. Outside the parentheses, adding will be up. Subtracting will be down. A number in front is going to make it vertically stretch. Again, just like as if we had any other function on the planet like x squared. Okay, so today we're going to talk specifically about tangent because for the next 2 days we're going to spend a lot of time on sine and cosine, which are really the more important ones. Okay, so we're going to be working with this parent function. So our parent function right now that we're working with is function is going to be y equals tan x. So that's the one that we're going to work with for today. Okay, again, tomorrow we'll come back and we'll work more with sine and cosine. Okay, so let me show you what our graph of tangent looks like. Let me pop over here to Desmos really quickly. Turn this on and this off, and that looks like a nightmare. Hang on one second. Let me make my scale a little better. I'll need to go to that bigger scale again here in just a minute. Give me just a second. Let me make my scale a little better, and it'll look less like a nightmare. Okay, there we go. All right, so this is what our graph of just the basic parent function of tangent looks like. And so last week we talked a little bit about how one graph or one piece is what we call a period. So for a tangent graph, one piece or a tangent graph repeats every time I have an up like this. I have an asymptote, which you can't quite see on here, but you can kind of see that we have a barrier right there. So there's my asymptote, and I have a down. Okay, so I have an up, an asymptote, and a down. And every time I have that, I'm going to have one period of tangent. So you'll notice on here that I'm starting at 0. I have an up, an asymptote, and a down by the time I get to pi. So the period of my tangent function, for just my parent function, is going to be 1 pi. So let me write that down back over here. So I'm going to say that the period is going to be 1 pi. Okay, so every time we work with tangent, the period's going to be 1 pi. And I'm kind of making a big deal about that because tomorrow our sine and cosine graphs are going to happen in 2 pi. So it's going to be a little bit different for those. Okay, so let's talk about how to kind of move these around. I'm going to write down just our basic form of an equation that goes with a trig function. So jot this down really quickly. And again, we're going to play a lot with this tomorrow and Friday with sine and cosine graphs. Okay. I wrote the word trig in here because this is where I'm going to put the type of trig function that I'm using. So I could have something like y equals a sine bx minus c plus d. Or I could fill in cosine right there, or I could fill in tangent right there. So whichever trig function you're working with, right there where I have that trig boxed in, that's where you're going to replace that with the type of trig function you're working with. Okay. Like I said, the minus c is going to make you go left and right, and we'll talk more about that tomorrow. The d is going to make you go up and down, and the a is going to give you a vertical stretch or compression, and we'll talk about all three of those things tomorrow. For today, we're focusing on a horizontal stretch and compression. And what's going to affect that is the b value right here. So it's going to be the number that's in front of x. Sometimes it is inside parentheses, and sometimes it is not. But it is always the number that's in front of x. Okay, so that b right there is what's going to make something stretch or compress horizontally. And again, it's going to be opposite from what you would think. So if I have an integer right there, kind of like I have this 2, it's going to have a compression. If I have a fraction for b, it's going to be a stretch. So it's a little bit opposite from what you would think. And so because of that, when I have something that's moved around and it's not the parent function, I'm going to find the period by doing pi over b. So I'm going to take that number that's in front of x, and I'm going to divide it into pi. And I'm going to circle that because that's going to be a really important formula that we're going to use kind of a lot today. Okay, so that right there is a really important formula to have. Okay, so let me bounce back over to Desmos just a minute, and I'm going to show you what this graph of 2 times the tangent of 2x looks like. So let me go turn that one on. Here it is right here. Okay, so when I go and I multiply x by 2, you can see those are the graphs in blue, and they happen more frequently. Okay, so I had my original function of tangent is the one that's in red. That's this one. And now my new one is happening more frequently. It's the one that's in blue. Okay, so if I think about the scale of this, I'm going to say that each of these little lines is 1/4. So I'm going to have 1/4 and 1/2 and 3/4 and 1. But I'm working in terms of pi, so this is going to be pi over 4, and this is going to be 3 pi over 4, and this is going to be 5 pi over 4. And I can go backwards and say that this one is negative pi over 4 and negative 3 pi over 4. And notice every time that I hit those, I'm hitting a vertical asymptote. Okay, so if you look, you can see the graph kind of tapering off right here. And that's happening at all of my pi over 4s. So I have 1 over 4 and 3 over 4. And there's another one right here at 5 over 4. And so that's where all of my vertical asymptotes are happening. Okay, so let me jump back over here, and I'm going to start by finding the period. Okay, so the period of this thing is going to be 1 pi divided by the number that's in front of x. So in this case, that's going to be at pi over 2. So I have a new tangent graph happening every pi over 2. Okay, so that's what the period means, is how long is it before a new tangent graph starts. So a new tangent graph is going to start on this one every pi over 2. Okay, so we just said that over there on my graph, I have a vertical asymptote at negative 3 pi over 4, and at negative pi over 4, and at pi over 4, and 3 pi over 4, and 5 pi over 4, and at all of my over 4s in both directions out into infinity. Bless you. Now, I don't want to go and list all of those pi over 4s out into infinity. Okay, it would take an infinite amount of time, so we don't want to do that. So the way that we're going to list them is using a pattern that looks like this. First of all, I'm going to start with x equals. Vertical asymptotes are x equals lines. I'm going to start with the one that is positive and closest to the x and y axis, to the origin. So I'm going to start with pi over 4. And I'm going to say that my first vertical asymptote happened at 1 pi over 4. And then because I know the period is pi over 2, I know my tangent graph is repeating every pi over 2. So I'm going to say that it repeats then at every pi over 2 times n, where n is an integer. Okay, so I could plug in for n. I could plug in 1. I could plug in 2. I could plug in 3. And I won't. This right here is my answer. But that gives me the capability of continuing out into infinity. Okay, so because n can be any integer, that n is going to give me the capability of continuing both directions, bless you, positive and negative into infinity. Okay. All right. Okay. So right there, I had an integer in front of x, and I'm going to go ahead and label that I had a horizontal compression. So number 1, it compressed or it shrunk. If you like the word horizontal shrink better, that's okay, because there was an integer in front of x. So in other words, if you think horizontally, it compressed in horizontally, and it happened more frequently on the x-axis. happened more frequently on the x-axis. Okay. All right, let's take a look at number 2. So on number 2, I'm going to start by rewriting this the way that we would normally see that point 1, and that's like this with a 1/10. And again, sometimes the number in front of x will be inside parentheses, and sometimes it will be right in front of the parentheses, but it's always the number that's between the trig function and x. Always the number between the trig function and x. Okay. All right, so with an integer in front of x, it horizontally compressed. With a fraction in front of x, what's going to happen to it? That's right, it's going to stretch. Good. So again, it's going to go kind of opposite from what you would think. Okay, so this time I'm going to have a horizontal stretch. All right, let's go and find the period for this one. Okay, for the period for this one, I'm going to take pi, and I'm going to put it over b. So I'm going to do pi divided by 1/10. Okay, what do I do when I'm dividing by a fraction? That's right, good. Keep it, change it, flip it, or multiply by the reciprocal. Good. So I'm going to keep it, change it, flip it. I'm going to multiply by 10 this time, and that's going to give me a period this time of 10 pi. So on number 1, my period was pi over 2. It was very, very small. But now I'm going to stretch this thing out, and it's going to happen, a tangent graph is going to happen every 10 pi. Okay, let me show you what that looks like. And give me just a second to work on my window here again. Turn that one off and this one on. Okay, so again, the red is my original graph. This is why it was so big when you first came in, because now we need to stretch it out all the way to 15 pi. Okay, so red is your parent function. See how frequently that one is happening? But now the purple one is my stretched horizontally graph. This is the one with 1/10 in front of x. Now I'm going to turn the red one off just so it looks less like a nightmare. Okay, and there's my new graph. Okay, so now you can see that I've got an up, I've got an asymptote right here at 5 pi, and I've got a down, and they're all happening between 0 and 10 pi. Okay, so one tangent graph is an up, an asymptote, and a down. Okay, and all of that's happening in that one period of 0 to 10 pi. Okay, so this question's asking me about vertical asymptotes. All right, so if I look at this one, I've got a vertical asymptote right here at negative 5 pi. I've got another vertical asymptote right here at 5 pi. If I kept going out, I'd have another one at 15 pi and negative 15 pi. So let me make a list of some of those real quick. So I'm going to write down negative 5 pi and 5 pi and 15 pi. And again, they go out into infinity in both directions. Okay, they're going to go out into infinity in both directions. So here's where I see my vertical asymptotes on my graph. And again, they continue in both directions. Okay, so to write that, because again, I don't want to list them out into infinity, I'm going to start with my first one. The first one that's positive is 5 pi. And then this time they happen in my period. So every 10 pi times n, where again n is an integer. So that n value will continue out with it into infinity in both directions, because n could be 1 or 2 or 3. N could be negative 1 or negative 2 or negative 3. So that n value being in there keeps it moving in both directions. And again, you don't ever want to fill anything in for n. It's a part of the formula. Okay. All right, so number 3 asks us to generalize it. So in other words, we're going to make a formula that we can use in all situations. Okay, so when they ask you a question about vertical asymptotes, I'm going to start with x equals. A vertical asymptote is always an x equals line. All right, and then if I look at what I have here, let me start with this one on number 2. I had a period of 10 pi, and I started at 5 pi. 5 is half of 10. Okay, on this one on number 1, I had a period of pi over 2. I started at pi over 4. Pi over 4 is half of pi over 2. So the formula is that I'm going to start with 1/2 times the period, which we'll find by doing pi over b. Then I added to it, for example, on number 2, I added 10 pi, which was the period, so pi over b, and I'm going to multiply that by n, where n is an integer, and again, that will keep it going into infinity. Okay, so what you'll want to do when you go to answer questions about this is fill in for b, but never fill anything in for n. N will just stay in the formula. Okay, you don't need to fill that one in. I know that's hard to say. Shut up. Okay. Okay, so all of your answers will be something with pi over b plus some kind of pi with b times n, where n is an integer. Okay, a and b being negative have no effect on the vertical asymptote formula.
Attention teachers, that was the ADA bell. Please take your ADA attendance at this time. Thank you. Have a great day.
So question number 4 asks you about A being negative and B being negative. A is going to be a vertical reflection. B is going to be a horizontal reflection, but the asymptotes stay where they are. Okay, the asymptotes stay where they are. So it will affect your graph, but it will not affect your formula. Okay. The last thing they'll ask you about on the homework today are the x-intercepts or the zeros. Your formula for that is still going to be x equals, and you're just going to take the period pi over b and multiply by n, where again n is an integer. The y-intercept or zeros. Yeah, I'm sorry, x-intercept. I said y. X-intercept or zeros, use that formula right there. Okay. Okay, so turn to the homework page and let me show you where to use all of these formulas. I'm not going to work any of these. They go really fast, and then we're going to do a little Desmos activity. The first 4 questions are asking you about the period. They're just asking you to plug in pi over b. Again, remember, if you're dividing by a fraction, to use keep it, change it, flip it, or multiply by the reciprocal. 2, 3, and 4 are all fractions where you'll need to use that. Okay, so 1 through 4, you're just plugging into pi over b. All right. 5, 6, and 7, they're asking you about vertical asymptotes. This is where you want to use the vertical asymptote formula that looks like this, that we just wrote down. Okay, again, all you're doing is plugging in for b on those. Again, if you get a b value that is a fraction, don't forget to multiply by the reciprocal or keep it, change it, flip it. And then finally down here is the zeros or the x-intercepts, and we're just doing pi over b times n. Okay, so really on the homework for today, numbers 1 through 11, all you're doing is just plugging into those formulas, just getting some practice with that. 11 is just a question about what did you notice as you were going through. Yeah. Good. Okay. Okay, what I'd like for you to do next is in Desmos. So let me tell you what you're going to do first, and then I'll give you some time to work. So in Desmos, we're going to go and we're going to explore the idea of the sine, cosine, and code in Schoology. So the first thing you're going to want to do is go to Schoology under current unit. The only unit in there is 4B. And go to today's folder. And in today's folder, I have left you some instructions. It's right here. It says Desmos Graphing Activity. And it tells you to go to desmos.com and then use this one right here. So everybody look at this. Use the one that says 4th period. I had some 3rd period, go to 2nd period. So use the one that says 4th period. There's the class code right there. Okay, so join my class. All right, so then in Desmos, this is kind of what it's going to look like. Let me jump out of that if I can remember how. All right, so here's what it's going to kind of look like when you get in. And what you'll do is play around with these sliders right here. So you can make A get really big, and you can make A get really small. And then you'll go to the next screen and answer a question about what was happening with A. Now, if you've forgotten, you can always go back and play with the slider again. Okay, so play with the slider, then go to the next screen and answer the question, and again, you can go back and forth. There's an option to share answers with class. You do not need to do that. You can if you want to, but you don't need to. And also, this thing auto-submits. It's actually kind of cool because I can actually see your answers as you're working on it, like live. So you do not need to submit at the end. When you're finished with the last one, you can just X out and it will auto-submit to me. So it saves as you go. Okay? Any questions about the Desmos activity? Okay,